Have you ever really thought about that perfect, fleeting moment when a line just grazes the edge of a circle? It seems so simple, right? But it's actually more than just a simple touch. It's a relationship that's governed by some really precise and, honestly, beautiful rules. So let's dive in and uncover the secret geometry of tangents. First things first, let's ask the most basic question we can. If you've got a line and a circle sitting in the same space, how can they actually interact? You might think it's obvious, but there are a few very distinct possibilities we need to get straight.
So it turns out there are really only 3 ways this whole thing can play out. 1, the line can just completely miss the circle. Simple enough, we call that a non-intersecting line. 2, it can slice right through it, hitting it at 2 different points. We call that a secant. But the third case, that's the one we're really interested in today. That's the tangent. It's that perfect, just touching moment at one and only one point.
Right, that single point of contact is where all the magic really happens. So for the rest of this explainer, we're going to zoom right in on the tangent and all of its unique, kind of secret properties. But before we get to the rules, let's just pause and really think about this. What is a tangent, really? Is it just some line that happens to randomly touch a circle at one spot? Or is there a more dynamic way to understand how it's created? Well, here's the secret. The best way to think about a tangent isn't as a totally separate thing, but as the ultimate evolution of a secant. Let me show you what I mean. Okay, imagine a straight wire, like a needle, and it's pivoting around a fixed point on the edge of a circle. At first, it's a secant, right? It's cutting through at your pivot point and some other point. But as you rotate it, watch that second point. It starts sliding along the curve, getting closer and closer and closer until, poof, the 2 points merge into one. At that exact instant, your secant has literally transformed into a tangent. Or, hey, here's another way to picture it. Start with a secant again. Now imagine you're just sliding parallel copies of that line outwards, away from the circle's center. The little line segment inside the circle, the chord, it gets shorter and shorter, until at the very last possible moment before the line completely leaves the circle, that chord's length shrinks to 0. The 2 points have become 1. And boom, you've got a tangent again. So here's the big takeaway from all that. A tangent isn't just some line that happens to touch a circle. No, it's the limit of a secant. It's that super precise moment where its 2 intersection points finally merge into a single point of contact. So now, with that understanding, we can lock in the official definitions. A tangent is a line that intersects a circle at exactly 1 point. And that one special spot, we call that the point of contact. Okay, so now we get what a tangent is. Let's start uncovering its secrets. And the first one is its most fundamental property. It's a super simple rule that just perfectly describes how a tangent relates to the circle's center. Just think about it for a second. If you draw a line from the very center of the circle out to that single point of contact, what kind of angle does it make with the tangent line itself? Is it sharp, wide, something else? The answer is just beautiful. And its simplicity, it's always a perfect 90-degree angle. The radius and the tangent are always perpendicular at that point of contact. Every single time. No exceptions. But why? Why a right angle? Well, the logic behind it is actually really elegant. Think about it. The point of contact is the single closest point on that entire tangent line to the center of the circle. Right? Any other point you pick on that line is, by definition, farther away. And a fundamental rule of geometry is that the shortest distance from a point to a line is always the path that's perpendicular to it. So it has to be a 90-degree angle. Simple and so powerful. Okay, so that's rule number 1. But let's switch things up. What if you start with just a single point somewhere in space? How many tangents can you draw from that one point to a circle? Well, it turns out the answer completely depends on where that point is located. And it's pretty intuitive when you see it. If your point is inside the circle, you can't draw any tangents. Every line you draw is just going to be a secant, cutting right through. If your point is exactly on the circle's edge, well, we already figured that one out, you can draw exactly 1. And if your point is outside the circle, you can draw exactly 2 tangents, 1 to each side of the circle. And that last case, the one where you're drawing 2 tangents from a single point outside the circle, that leads us to another really, really neat rule, our second secret. So picture it. You're at a point outside the circle. You draw your two possible tangent lines. Now, if you were to measure the length from your external point to where each line touches the circle, what do you think you'd find? That's right. The lengths of those two tangent segments are always identical. It's another one of those perfect, unbreakable rules of geometry. And the reason why is just so cool. If you draw a few extra lines, one from the center to your external point, and two more from the center to each point of contact, you suddenly have two triangles. Now, thanks to our first rule, we know these are both right-angled triangles. They also share the exact same long side, the hypotenuse. And two of their other sides are just the circle's radius, so of course they're equal too. So what you end up with are two triangles that are perfect mirror images of each other. And if the triangles are identical, it means all their sides are identical, including the last remaining sides, which are, you guessed it, the tangent lengths. They have to be equal. Now, I know you might be thinking, okay, this is all very neat geometric theory, but does any of this actually show up in the real world? And the answer is a huge yes. Tangents are, quite literally, all around us. Seriously, just think about a simple pulley lifting a bucket from a well. The rope leaves the circular pulley at a tangent. A bicycle tire touches the road at a single point of contact. That's a tangent that moves as the wheel rolls. And look at any machine with a belt or a chain, like your bike chain on its gears. The straight parts of the chain are perfect tangents between the circular gears. This whole principle is absolutely fundamental to how we transfer motion smoothly in all kinds of machines. So, you see, these geometric rules aren't just abstract ideas in a textbook. They are the hidden principles that make our world work, from gears to tires to even the path that light travels. Now that you know how to see this perfect, fleeting touch between a line and a circle, where else are you going to spot it?